Assalamualaikum and hello everyone. My name is Muhammad Farizul bin Muhammad Fatihi and I would like to present my final year project, which is evaluation of anti-diabetic and anti-inflammatory activities of Melastoma malabathrium white flower variety in different extraction methods. This study aims to explore the medicinal properties of white flower of M. malabathrium and to compare ethanol, methanol, and aqueous extraction methods in yielding optimal bioactive compounds. The objective for the studies are to evaluate the anti-diabetic and anti-inflammatory properties of white M. malabathrium flower in different extraction methods and to determine the metabolites that are present in different extraction methods of white M. malabathrium flower. I believe this study can fill the knowledge gap in the lack of studies on anti-diabetic and anti-inflammatory properties for white flower variety of M. malabathrium, and the lack of studies that compare the optimal extraction method for anti-diabetic and anti-inflammatory properties of M. malabathrium. M. malabathrium, or commonly known as sendudok, has been used traditionally to treat thrush, diarrhea, scrapes and wounds, hemorrhoid, dental infection, and stomach aches. There is also a study that proved the anti-hyperglycemic activities of M. malabathrium leaves using alpha-glucosidase inhibition test. For our information, people with obesity may develop diabetes due to the inflammation of adipose tissue. Due to this reason, anti-inflammatory test was conducted together in this study. The methodology in this study was started with sample collection of dried flowers of M. malabathrium from Langkawi Island. Next, the bioactive compounds of the flower were extracted using ethanol, methanol, aqueous maceration, and aqueous decoction extraction methods. After that, these samples were tested for anti-diabetic and anti-inflammatory properties using alpha-glucosidase inhibition test for anti-diabetic test and bovine serum albumin denaturation inhibition assay for the anti-inflammatory test to answer the first and second objective respectively. Lastly, to answer the third objective, liquid chromatography mass spectrometry was conducted on all the samples for compounds identification. As for results and discussion, first, we will look at the result for anti-diabetic tests. All samples were positive for anti-diabetic activity similar to the previous study of M. malabathrium, except for aqueous decoction sample. Linear relationship of percentage inhibition for each triplicate of the samples has been plotted to find the inhibitory concentration of 50% or IC50. This is the linear relationship of percentage inhibition for M. malabathrium ethanol extract, which has an average of IC50 of 4.072 mg per milliliter. This is the linear relationship of percentage inhibition of M. malabathrium methanol extract, which has an average of IC50 of 6.117 mg per milliliter. This is the linear relationship of percentage inhibition for M. malabathrium aqueous maceration extract, which has an average of IC50 of 1.860 mg per milliliter. This is the linear relationship of percentage inhibition for M. malabathrium aqueous decoction extract that does not show any anti-diabetic activity and does not have IC50 value. For statistical analysis, the ANOVA test shows that there is a significant difference between the IC50 of anti-diabetic activity for each group where the p-value is less than alpha value of 0.05, and post-hoc test results show that aqueous decoction sample has significant difference in the IC50 compared to ethanol and methanol samples. Next, we will look at the anti-inflammatory results. The table shows the absorbance reading for all the samples using microtiter plate reader. Unfortunately, the IC50 of anti-inflammatory for all samples cannot be calculated due to the failure of negative control to work properly. This is perhaps due to the temperature that I used to denature the bovine serum albumin or BSA protein was not high enough, and the duration of heating process was too short. Finally, we look at the LCMS results. Based on the LCMS results, these are the top 10 compounds with the highest peak recorded for each samples. For the ethanol sample, there is one compound responsible for anti-hyperglycemic activity based on the previous study identified, which is choline. For methanol sample, there is one compound responsible for both anti-hyperglycemic and anti-inflammatory activities based on previous studies identified, which is quercetin. There are no compounds responsible for anti-diabetic and anti-inflammatory activity present in the top 10 list for both aqueous maceration and aqueous decoction sample. For conclusion, the anti-diabetic properties of white and malabathrium flour in different extraction methods was successfully evaluated by the determination of IC50 value for all samples. Unfortunately, the anti-inflammatory properties of white and malabathrium flour in different extraction methods cannot be evaluated due to errors in the experiment. Lastly, the metabolites that are present in the different extraction methods of white and malabathrium flour has been successfully identified by conducting LCMS. The recommendations I can suggest for this study is to make further research on anti-diabetic and anti-inflammatory properties for the metabolites that has been identified using LCMS. Next, in vivo studies are recommended to test the efficacy and safety of all the extracts before clinical evaluation. Lastly, assay that does not require the absorbance reading is recommended, so the sample color does not interfere with the absorbance value. That is all from me. Thank you.